All right, folks, so this is chapter 6 of our VB book. And in this chapter, we're going to be focusing mostly on loops, but we'll be introducing a few other things. As has been the case with the last few chapters, I will be embedding some questions into this presentation for you to answer to ensure that you've gone through this whole presentation and listened to it. I think I'm going to have 4 questions in this one instead of 3. But again, they'll be very simple questions for you. You should be able to follow right through. So let's just get into it. Oops. So the first new object that we're going to be introducing in this chapter is the MenuStrip object. So what this is going to allow us to do is clean up our user interfaces a little by putting menus in our application. So rather than having an exit button, you can put all that stuff onto the menu and clean up our interfaces. The other new object that we are going to introduce is the InputBox function, which is kind of a combination between a message box and a text box. So we're going to use some loops. So rather than putting, if we want to enter 10 pieces of data, rather than putting 10 text boxes in your application, you can just use an input box inside a loop, and it displays for as many times as you need it. We'll introduce another new object called the ListBox, which is just pretty much what it describes. Along the text box, it's a list of items. So rather than just putting one item in a text box, you're going to be able to put multiple items in there. We are going to introduce adding background images to your forms. Not something I'd like to do. I think adding a background image to a form makes a form really busy, but some people like to do it, and we'll show you how to do it. It's not really something that's going to take a lot of time. We'll introduce the concepts of counters and accumulators. These are something that we use with our loops to kind of keep track of where we are in the loop and kind of sum up the data that we're counting in the loop for averages or sums or whatever. We'll talk about compound operators, and we'll talk about the 2 main types of loops that we'll be introducing and you'll be using in this chapter for next loops and do loops, and there's 2 types of do loops that we'll introduce. We'll talk about the danger of infinite loops. We'll talk about priming your loop or getting it started. Talk again about validating data a little bit. We talked about that a lot with our last chapter, and validating data is still going to be important with this chapter, so we'll spend some time on that. We'll talk about nested loops. You could nest. We talked about nesting if statements in the last chapter, and in this chapter we're going to be also nesting. You can nest an if loop inside a loop. You can nest a loop inside an if statement, and that can be inside a loop. So we can go many layers with our nesting. I don't think any of the cases in this chapter you'll have to do nested loops, but you will be nesting your loops inside if statements, but there will be no loop inside loops. And we'll talk about, and this is kind of a hard thing to determine when you're just starting, but when to select the best type of loop to use for a certain situation. So and that's something that's going to come with experience. You're not going to figure that out at this chapter, but that's kind of part of the learning experience with this chapter. You're going to try out the different types of loops, and you'll find that some work better in other situations, and that's something that you'll have to learn on your own by trial and error. You know, you'll try to use one loop and say, it just doesn't work good for this situation, so maybe I'll try to use another loop. And that's how you learn how the loops work. Maybe the most important thing that we'll introduce in this chapter is debugging and breakpoints. So what that is going to allow you to do is you put what's called a breakpoint inside your code, and then when you run your code, the code will stop at that breakpoint and allow you to step through your code line by line and analyze variables and what's in those variables. And this is important when you have errors in your code. Your application crashes and you're not sure why, or the application is not calculating something as you expect it to. This will allow you to analyze the individual lines of code and determine where it's going wrong. probably, I think, one of the most important things that you'll learn in this chapter is how to use debugging. And I think I introduced it to a couple of you in the if then else statement chapter. If when I was working with you, you had an issue that was kind of hard to debug, it makes it a lot easier when we put a breakpoint in, but I know I didn't show it to everybody. So this is a chapter where we'll really start digging into using debugging. The last thing in this chapter that they introduce is publishing the application using click once technology. All that allows you to do is create a setup file, the executable, so you can install the application on multiple computers. So we won't spend a lot of time on that. You probably won't ever need to do it. It's very, very simple. All you do is, it's a button click. You click and you click publish the application, and it just makes a setup file for you. Pretty simple. Not much to it. So the fundamental process in a program, the programs that you're creating, is to repeat a series of instructions either while a condition is true or not true, or until a condition is true or not true. The process of repeating a set of instructions while a condition is true or until a condition is true is called looping. Another term is iteration. So this is the guided program development you'll do. So it's a fitness challenge app where you have a team and you're trying to see which team has lost the most weight. So in this application, you have 8 or 10 members of the team, and you accept input for each of those members with the amount of weight loss. And then, so the application captures all those values and then takes an average of all of those numbers together. So not a whole lot here. So there's, a couple ways you could do this. You could put 10 text boxes in here and capture these items 10 times in 10 text boxes and do the average manually. Or it's a little more efficient to do it using a loop. So that's what we're going to use with this chapter. You'll also notice in this chapter that rather than having a lot of buttons in here, a clear button and everything else, there's just a file menu in here. So we're going to have our applications look a little cleaner in this chapter by putting a lot of our functionality or user interface functionality in our menu. And those are really simple to use in Visual Studio. So that'll be something nice to introduce to you. So the object we'll be using for our menus is a MenuStrip object. So we have a menu bar, and that's just a strip across the top of a window that contains one or more menu names. So that's just our strip. So our menus will be pretty simple. We'll just have file. And your menu is a group of commands. So your menu bar is the bar that goes across the top, and the menu is actually the part that drops down. So in this example, you're going to click on the file, and then this will drop down, and you'll see clear and exit. So rather than having buttons for those two items, you'll just have them on your menu, just to clean up the user interface. Just an example of what the menu looks like. Naming conventions for menus are MNU. And we'll get into that a little more when I do the chapter walkthrough. I'll walk through how to drop them on the screen. It's pretty simple. It's not a whole lot to it. And how to name them, and we'll even do some shortcuts with them. Menus have event handlers just like buttons and everything else. So you double click on the menu. In this case, the close or the exit section of the menu, and it opens up an event handler just like the exit button. You put your code in there. It behaves exactly the same. You can also insert standard menus. So in most Windows applications you've looked at, think about Microsoft Word or Excel, you have a standard file menu. So that's just something you can drag from the menu bar and put in your application if your application needs that. Our application is going to be pretty simple. We're not going to need file open, save, print, or anything like that. But Visual Studio does have that functionality, so you can do that if you want to. And there may be opportunities to do that later in the year when we get to more complicated applications, but not just yet. But it's good to know that the functionality exists. So the next new function we're going to introduce in this chapter is the InputBox function. So the InputBox function displays a dialog box that consists of a message asking for input, an input area, a title, and an OK button, and a cancel button. When the user enters text and clicks OK button, the InputBox function returns this text as a string. If the user taps or clicks the cancel button, the function returns a null. So when you type in the code for InputBox, and in the next screen I'll show you what the InputBox looks like. It looks similar to a message box. The only difference is the InputBox has a text box in it that you can enter some data in. So when you put this code in, wherever the code is, if it's on a button or whatever, the InputBox pops up, and what will get displayed is a message and a text box. You put whatever you want in that text box, and whatever goes in that text box you assign to a string variable, and then you do whatever you want to do with it. So this is what an input box is going to look like. So we have a menu portion of it, we have a message, OK and cancel button. So there's no validation on this, so all the validation, it's just like a text box, so everything's going into a string. So you're going to have to do the validation back in code. And this is just a simple, the code that you would do. So you declare your variable, whatever you put in this input box, this age, for example, is going in the input box, and that's going to be assigned to this string age variable. So not a whole lot to it. Input boxes are something that are specific to Visual Basic. You're not going to see them in C# and not a lot of other languages. But it's kind of nice functionality, especially when you're doing business type applications. We need to get input, and you didn't want to mess up the GUI. So you can also assign a default value to an input box if you want to. So if you know the user is usually going to be entering something, but they want to override it, the third parameter here is the default value, so that can be assigned as well, which is kind of nice if that's the situation that you need to use it for. And this is just an example of how we're going to be using the input box in the guided program walkthroughs. A little bit of sample code here. We've got some variables here for the messages, so we're not hard coding the messages here in our input box. We're setting them in our variables and then assigning those variables later, just to kind of clean up this line of code here. And we'll dig into that a little bit more when we get into the guided program walkthrough. Okay, so question 1 for this chapter is, what is the difference between an input box and a message box? Again, question 1, I want to know the difference between an input box and a message box. All right, so the next object that we're going to be introducing in this chapter is the ListBox. And a ListBox is just what it says. It's a list. It's an object that allows you to put a list of items into. Okay, so rather than a text box, it's just one item. It's actually really what it is. It's an array. It's a variable with multiple items in it, and you can sort through those items. You can reorder them. You can do all kinds of. They're distinct items in a list. Okay, ListBox naming conventions is LST, and we'll be using ListBoxes in this chapter to capture lists of data for a couple of the applications. Not all of the applications you'll have to use. Well, I think you'll probably have to use ListBoxes for all the applications, but I don't think you'll have to use input boxes for all the applications. And we'll talk about that a little as we get into the cases. So this is an example right here of the ListBox capturing all the weights. In order to add a value to the ListBox, the syntax is the ListBox name.items.add, and then whatever you want to add. So you use a variable. The variable is probably going to be referenced from the item in your input box. So another example here. List weight loss items.add, and then You could hard code a value here. In this example, we're just capturing the value that we captured in the input box and then convert it to a decimal. And we'll do this in a loop, so we'll have to do that in one line of code, and it just loops for as many times as we need. It looks like this example in the guided program walkthrough, we're collecting 8 distinct weight values. So if you want to clear out your items that are in your list box, so in our previous chapters and cases, we had a clear button. So listbox.items.clear will clear out all the values, delete all the values from your list box for you. Okay, so that's a built-in function, just like the clear function for the text box. So if you want to reference a specific item in the list box, the syntax for that is listbox name, so your name of your listbox dot selected item, and that's going to reference whatever item in that list box you've clicked or selected. If you want to do something with that item, this is the syntax you would use. So you get that selected item from the list box, whatever one the user's clicked on, then you can put that in a variable and do something with it. So think about an application where a list of states is in a list box and the user selects one and you want to do that, you want to save it to the database. This is the syntax you would use. So this is just showing you in this example that they've added a background image to this application. Again, as I mentioned in the introduction, I really don't like background images in applications. I think it makes them look messy. I even hate the colors they're using in this application, the green background for the text boxes. So feel free to make this GUI a little better. I guess it matches the green apple, but I think it's just awful. But feel free to use a background image and make this GUI better if you want. I think it's hard to read the fitness challenge team weight loss because of the background. There's not enough contrast, but do with it what you will. Feel free to make the GUI better. So the first thing we need to talk about in this chapter before we introduce loops is a concept of accumulators and counters. So a variable that contains an accumulated value, such as a total of all weight loss values, is called an accumulator. A value that allows, that is always, a value that always is incremented with a constant value is called a counter. So these are two things we're going to use inside our loops. Counters are used to kind of keep track of how many iterations you've gone through the loop. So in the guided program walkthrough, we're going to be capturing 8 items or 8 people's weight loss. So as we're going through the loop, we need to keep track of how many times we've gone through so we know when to stop. We use our counter for that. The accumulator, as you're going through, we're going to want to take an average of those weight loss, In order to take an average, you have to take a sum and then divide by the number. So we use the accumulator to sum up those values. So as you're going through the loop, you're going to be accumulating and capturing those values. Okay. So question 2 is I want you to tell me what the difference is between an accumulator and a counter. Again, I'll just repeat that. Tell me what the difference is between an accumulator and a counter. And this will make a lot more sense once you start coding, but it's good just to kind of start thinking about it now. All right, so the next thing that we'll introduce, and this is something that you're going to see in a lot of programming languages, compound operators. So all compound operators are is a shorthand way of writing things. So in your loops, you're going to be adding things to your accumulators and adding things to your counters. So the way you would write that is int result equals int result plus 1. So for your counter, you just add 1 every time through. Another way to write that, a shorthand way to write that, is int result plus equals 1. Okay, so instead of repeating that int result, you just kind of combine the equals and the plus as plus equal, and these two things mean the same thing. You can do the same with subtraction, multiplication, division. It's just a shorter way of writing things. It's okay to write it, the long way like this, but you don't have to. And in the examples, we'll use these compound operators a lot because it's faster for us. And once you get used to seeing it, it'll make a little more sense when we go through the guided program walkthrough. So this is an example of using compound operators to do some math. So we're starting with 7, and we add 6 to 7. So plus equals, we're just saying whatever's in total. So we put 7 in total. And we're just adding 6 to that. So 7 and 6 is 13. And then we're multiplying it by 2. 13 times 2 is 26. Divided by 13 is 2. Okay, so that's all we're doing. We just accumulate the value in this total, and then we use the operator here to divide, to do the arithmetic. And we're putting, in this example, we're putting the result of 2 into a message box. You can use compound operators with concatenations too. I don't know why you would do this, but it's just an example to show that you would. I would just put this in one line, but they're just using it as an example, and that's fine. All right, in the fitness challenge application, the user enters weight loss values in an input box for up to 8 team members. The repetitive process of entering 8 weight loss values can be coded within a loop to simplify the task with fewer lines of code. So like I said, you could do this application with just 8 text boxes and just add those values up. It would be messy, it would be ugly, the GUI would be pretty nasty, but it could be done. But this is why we have loops, this is why we do programming. Each repetition of the loop is called an iteration. So the first type of loop, and I think for next loops are the easiest kind of loops to understand. First type we're going to introduce is a for next loop. So you can use a for next loop when a section of code should be executed an exact number of times. So for loops are good when you know exactly how many times you want the loop to iterate. So what you're going to do with a for loop is just give it a range. So for our control variable, which is just an integer, 1 to 8. And then the loop is going to loop that many times. You don't have to worry about counters with for loops because you've kind of put the counter into this range here, beginning and ending value. So they're a little simpler, a little easier to understand. But I do not want you to use for loops for every single case in this chapter. I want you to use one of each loop type that we'll be introducing, because I want you to kind of see the differences, see what makes one good and one better for certain situations. So here's a very simple example of a loop. So we have our control variable called int number. So we're saying for our control variable equal 1 to 4. So that's the range. We're going to loop 4 times. So this just shows you what happens. First time through, our int number is 1. It executes the code inside. In this example, there's no code inside. Goes 2, 3. When it gets to the 5th one, there's no 5. So the control value is exceeded. So we don't loop a 5th time. It just kicks out. A step value is something you can add to your loops, is a value in the for next loop that's added or subtracted beginning value in each iteration of the loop. So default, you don't have to have this. You probably normally won't have this. Default step is 1. It can be positive or negative. So this is if you want to skip values. So this would go 1, 3, 5, 7, 9. So it would skip a value. So you could do step 5. It would go 1, 5, 10, 15, 20. And there are situations where you might want to do something like that. Happens a lot with like very large numbers when you're working with like financial calculations and mortgages. Sometimes you do steps, so you don't want to loop every single time. Maybe you want to loop if you're doing yearly calculations and payments are going in monthly, but you only want to display a value once a year. You won't have to use any steps in this chapter, but again, this is just something introducing it to you so you know that it's there. So typically, you won't be using this step in this chapter. Just an example of a negative step, so you can also loop backwards if you want to. So we're starting at 25 and we're going to -10, and we're stepping backwards in a negative value with the step. Again, not something you're going to have to do with any of the examples in this chapter, but good to know that you can do it if you ever need to. And this is just another example. You can step decimal values. So if you needed to, you could step 0.1. So this would, be very, very precise in your loops, and you might have to do this if you're looping for some kind of a game or a very precise calculation. Like think about a physics engine for a game. Something very precise, you might want to use something like this. Again, not anything you're going to have to do with the cases in this chapter, but again, good to know that it's available if you need it. So for next loop can also include variables and mathematical expressions. So this range begin to end doesn't have to be a hard-coded number. It can be a variable, and it can also be an expression. So we can multiply in n times 2 to make that bigger, and our step can be a variable too. So those don't have to be hard-coded numbers. You can use variables for them as well, or expressions. So this is an example using a loop where we're looking at the Alaskan population at the beginning of a 6-year period, and our population in Alaska is growing at 5%. So we're starting our first year at 675, and we know the population is going to grow at 5% a year, so we're going to use a loop to do that. So for my years 1 to 6, we have our int Alaskan population. We're adding our first year population to our population plus 5%. We add that item into our ListBox, the year, and then our new population, and we're going to do that 6 times. And on the next screen, we see what it does. So the first year it added 5%, then it added another 5% to that. So a nice, easy way to calculate growth of a population. You're going to be doing, in some of the further cases in this chapter, you're going to be doing something similar to this to calculate interest on money in a bank. So this is where loops become very useful for calculating yearly interest. And it's basically the same calculation as you're seeing here. But this example is population growth. It's an example of handling user input. So in this example, they're getting their begin and end values from a text box, and then squaring each of those values. So we start with a min number and a max number, and then we're squaring all the values from that min to that max. So I'll show you an example of that, putting them in the list box and squaring them, multiplying it by 2, or exponenting it by 2. So in this example, we started with 3 and ending with 16. So we took 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. And that's something we did with just this simple loop right here. So this is where we squared it. And this whole line is what we added to this list box here. So kind of a cool, simple little app that you can do, kind of do some math for you. So the next type of loop we're going to introduce is a do loop, and there's two types of do loops. There's do while loops and there's do until loops. Okay, and there's different situations where you might want to use each of them for certain situations. So in a do loop, the body of the loop is executed while or until a condition is true or false. The do while loop executes as long as the condition is true, and the do until loop executes until the condition becomes true. Okay. Top controlled loop is tested before the loop is entered. The body might not be executed. And the bottom controlled loops test a condition at the bottom of the loop. And in bottom controlled loops, the body executes at least once. So we have do loops. Within do loops, we have do while and do until. And then within each of those do whiles and do untils, we can control our loops at the top and we can control our loops at the bottom. 99% of the time you're going to be using top controlled loops, but there are situations where you might want to use bottom controlled loops. So a top controlled do while loop begins with the keyword do while, and then next the condition is specified. Body of the loop contains instructions that are executed as long as the condition is true. A loop that does not end is called an infinite loop. So you will run into infinite loops if you do not have a counter inside your loop. So while you're executing this condition, you have to increment whatever that condition is looking for so the loop knows when to end. If you do not do that, the loop will run forever. Well, it won't actually run forever. It'll run until the memory in your computer fills up, which will happen eventually. Your computer will crash, or it'll just get really slow until you can't do anything. And some of you will accidentally create infinite loops. Your computers will get really slow. Unfortunately, with your laptops that you have, you can't end tasks, so you'll probably have to power your computer off and then remember not to run that program again until you fix the loop. So not a big deal. It's good to make that mistake a couple times just so you know. They're not the worst thing in the world. But an infinite loop ultimately is going to cause problems because they're going to crash your computer. So question 3 is, tell me what an infinite loop is. Again, question 3, tell me what an infinite loop is. All right, so example of our top controlled do while loop. So start with our control variable int score. So we say do while int score is less than 5. And this is what's going to prevent our infinite loop, incrementing this score by 1 every time. So this is going to execute until this int score value gets to 5. If we didn't put this in here, this loop would run forever. Okay, so if we look at our iterations, our score starts at 0. So this loop is going to actually execute 5 times. On the 5th time, on the 6th time, it's going to kick out for us because it's starting with 0, right? So it actually is going to execute 6 times, even though our score is 5. So a bottom controlled loop works the same way as a top controlled loop. It's just that the body of the loop is executed before the condition is checked the first time, guaranteeing that at least one iteration of the loop will be completed. Traditionally, you don't really care about that. You're going to be controlling with the loop, but if you know in a situation, there are some situations where you don't know, depending on what the user inputted, if the loop needs to execute once. The user put bad data in there. You don't need to, enter the loop. So by doing a top controlled loop, the loop will never get executed and the code will be a little more efficient. Is it that big a deal to execute a loop once? Is it going to slow down the application that much? No, probably not, but it's a more efficient way to do things. So typically you're going to use top controlled loops, but just know that a bottom controlled loop is possible. just might not be the most efficient way to do things depending on the way your application works. Just example of your bottom controlled loop here. So same example as before. Dim int score starting at 0. We do int score equals int score plus 1. So they're not using a compound calculation here. They're using the longhand. So we loop while int score is less than 5. And notice on this one, it only executes 5 times. So in this situation, it might be a little more efficient to do it this way if the user enters proper data, okay? Because it's going to execute it once and then kick out the 5th time through. So the next type of loop is do until loop. And do until loops can, again, just like do while loops, be top controlled and bottom controlled. So it looks very similar to the do while loop. Except we're doing it until a condition is true, not while a condition is true. So here's an example. What are we doing in this example? We're doing until, so this is, we're using, let's see, we're using a parking time and quarters. So do until decimount is less than 25, in quarters plus 1. Oh, so we're adding quarters to a parking meter for this one and determining the number of minutes. So do until decimount is less than 25, add quarters, and we subtract our quarters from the application for parking time. So bottom controlled do until loops. The last of the 4 do loops is a bottom controlled do until loop. This do until loop checks a condition after the body of the loop is executed. The loop continues until the condition becomes true. Do loops are often written to end when the user enters a certain value or performs a certain action, such as tapping or clicking a cancel button in an input box. And our applications are going to do this. We're going to do it until either 8 items are entered or the user enters, clicks a cancel button in the input box. So we talked a little earlier about an infinite loop. An infinite loop is a loop that never ends. So in this example, we have a while loop, but we don't have that counter in there. So this loop is going to display this message box forever. So you're going to hit OK on it. It's going to come up again. It's going to come up again. That's not the worst thing in the world, because the message box is going to stop it and it's not going to fill up your memory. So you're just going to get sick of clicking on it. You know, if you didn't have a message box and you just had some code in here and the code was accumulating a value, eventually that accumulator would either fill up the variable or fill up the memory in your computer, and the computer would crash. So we talked about infinite loops. We want to avoid them, but many of you will accidentally create infinite loops. Again, not the biggest deal. Just be aware of it. If your applications are running kind of funny, acting really slow, possibility that you've accidentally created an infinite loop. So the next thing we're going to talk about is priming a loop. So starting a loop with a preset value in the variable testing the condition is called priming the loop. So in this example, we're starting with our string canceled click as nothing, number of entries is 8, and int number of entries is 1. So we're capturing our first weight loss value. This is an example of the code from the chapter walkthrough. We're going to do until, and this is where we're priming our loop here. We're doing until our number of entries, which we're starting at 1, is greater than the max number of entries, which is 8, or string weight loss equals string canceled. So until we click the cancel button. So string canceled is nothing. So until we get, if someone clicks the cancel button, it's going to put nothing into that string canceled variable, and it'll kick out of the loop. So then inside here, we add 1 to our int number of entries. So if our int number of entries is less than our max number of entries. So we've incremented it here. Then we want to get another value from our input box, put it in straight string weight loss. There's some code missing from this one because we do want to accumulate that value. But this is basically what we're going to be doing in the chapter walkthrough. So we'll get into this a little more in the guided program walkthrough. The important part of this is priming the loop, where you're setting these two variables here and using them in the control as control variables inside the loop. This is what the whole application is going to look like. So in here, we have our do until, we check up numeric, so this is our validation. We capture our value that was entered in the input box up here. If our weight is greater than 0, we add it to the list box. We accumulate it, we add 1 to our counter. We set our input box message. Otherwise, we display a negative message. Our else for our if here is if it was not numeric. And then at the end, we check if our int number of entries is less than or equal to our max number of entries. If it is not, then we display our input box again and get another value. So we'll be going through this again in the guided program walkthrough. So any loop can be placed within another loop under the following conditions. Interior loops must be completely contained inside the outer loop, and they must have a different control variable. Like I said, I don't believe you're going to have to do nested loops here, but if you ever do, the important thing to remember is these control variables here have to be different. You cannot use the same control variable for the inner loop and the outer loop because it will get confused and you will not loop properly. So that's the most important thing, just making sure you use different control variable names. So I believe this is the example here from the previous code. So we're just looping for our, it's an outer loop for the week and an inner loop for the day. So this is something, selecting the best type of loop, it's going to take a little time for you to figure out. You're probably not going to figure this out until probably you get to the end of the chapter after you've gone through it a little bit. But basically you want to use a do loop if the number of repetitions is unknown and is based on a condition changing. For next loop is best if the exact number of repetitions is fixed. If a loop condition must be tested before the body of the loop is executed, you want to use a top control do while or do until loop. And if the instructions within a loop must be executed one time regardless of the status of the condition, use a bottom control do while or do until loop. If the keyword while, use the keyword while if you want to continue execution of the loop while the condition is true. Use the keyword until if you want to continue execution until the condition is true. So the do while and the do until, the differences of those, it's just kind of opposite. Okay, so really all you have to do when you're using those, if you want to kind of play around with how they work differently, is if you're using a greater than or less than, if you just flip that greater than or less than, you can switch between a do while or do until. And which you use is going to make more sense to you as an individual. So that's what you'll have to experiment with. You know, you're gonna use one loop and you're gonna say, this doesn't really make sense to me. Maybe try to use, if you were using the do while, try to use the do until. Okay, it's just kind of experimentation with what works best with your brain and your logic. So question 4, the last question we have are, what are the 3 main types of loops that we discussed in this chapter? So there are 3 types of loops. 2 of them are on this page. Actually, 3 of them, all 3 of them are on this page. So I want you to explain or just tell me what the 3 main types of loops that we discussed in this chapter. Okay. All right, so I think this is probably one of the most important skills you will learn in this chapter and possibly all year when it comes to programming, how to be a good debugger. So resolving defects in code is called debugging. A good way to collect information is to pause the execution of the code where a possible error could occur. Breakpoints are stop points placed in the code to tell the Visual Studio debugger where and when to pause the execution of the application. I will give a demo on this when I do the guided program development, but I'll also probably do a live demo on it in shop. And if you are running into a problem with this chapter and you reach out to me and ask for help because you're having a problem, figuring out what's going on, the first thing I'm going to ask you is, did you put in a breakpoint and debug? And I'm going to force you to do that because I want you to get used to debugging because it's going to be very, very helpful. While in break mode, you can examine the values and all the variables that are within the scope of execution through the data tip. So if you're having a problem with your loop, you're going to want to put a breakpoint in your code. And all you have to do that is just right-click on the line where you want the breakpoint to be. A menu will pop up and it's insert breakpoint. And usually you want to put the breakpoint before where you think the error is occurring. Okay, because you want to see what the values are before you jump into that code, especially with a loop. If you expect that your issue is with your loop, put the breakpoint before the loop starts. You don't want to put your breakpoint inside your loop because the error could have occurred before. And then all you do is hit the F11 key, and that allows you to step through your code line by line and examine all the variables and what's happening. You can just kind of watch the code execute. If you have a loop that's executing 5,000 times, you're probably not going to want to step through that many times, but there's other ways to get around that, and I can work with you guys on that. All of our loops will be fairly simple in this chapter. We're not going to be looping more than 5 or 10 times, so we won't have to worry about that. So when you put a breakpoint in, you're just going to click on the line of code. You'll right-click. It'll come up. Once you're done debugging, you want to remove that breakpoint, and it's the same way. You just right-click on that line. Something will pop up, and you'll have an option to remove the breakpoint. And usually, when you have a breakpoint in your code, a little red dot will show up on the line that you've put the breakpoint in to show you that there's a breakpoint there. You don't typically want to keep breakpoints in your code because it's going to stop every time you run. So you're going to want to remove those breakpoints when you're done. And again, I'll go through that with you guys. So the last thing in this chapter is click once deployment. So after an application is completely debugged, working properly, you can deploy the project. Deploying a project means placing an executable version of the program on your hard disk, on a web server or network server. When a program using Visual Basic 2017, you can create a deploy program using click once technology. Deploy version of the program you create can be installed and executed on any computer that has a .NET framework installed. So all you're doing is building a setup.exe. It includes your executable file and makes it really easy for someone to install your program. So if you're writing Windows programs at a company, you create these and you distribute it or maybe push it out to all desktops. So you can play with that. Not a big deal. It's not a whole lot to it. They make it really simple with this version of Visual Studio. Click once. All you do is click once and it creates the executable. In the old days, 10 years ago, when I was working with this, it was a lot more complicated before the .NET framework came along. But this makes it a lot easier for you. All right, so this is just the requirements for the guided program walkthrough. So you guys will step through that. And that's all I have for Chapter 6. Thank you very much.